Hello, Assalamualaikum warahmatullahi wabarakatuh, and hi. In this video, I will teach you how to use separable equation to solve first order differential equation. So to use separable equation, first the differential equation must be in either of these three forms. The first one, if we have dy dx equal to fx over gy, where fx is the function in terms of x only and gy is the function in terms of y only, then we can use separable equation because you can separate the variable x combined with the derivative dx, separate y from this function fx combined with dy. And the second form is dy dx equal to gy over fx. So this form also you can separate the variable y with dy, function x with dx. And lastly, dy over dx equal to fx multiply gy, where fx represent a function in terms of x only, gy represent a function in terms of y only. Given that a function where you can separate x and y, hence you can solve it by using separable equation. So let's see the methods of solution using this technique or separable equation. So if the given differential equation is not form of general form, you must reform that differential equation. So normally the differential equation given combine the variable x and variable y, but if you can rewrite or you can reform the differential equation to this form, either this one or this one or this one, hence you can solve it by using separable equation. Rearrange the equation by separating the variable x and y. So second is you rearrange by separating variable x and then multiply with dx, and variable y multiply with dy. So you put that left hand side and right hand side. Step number 3, integrate both sides of equation. So integrate left hand side, right hand side, and you put both on constants of integration just on the right hand side. Because left hand side also give you a constants of integration, then you are going to move it to the right hand side. So this will be just one constants of integration. Let's write as c. And number 4, simplify the general solution. If given condition, find the particular solution. So after you have integrate from the step number 3, after you have integrate, of course you will get the constants of integration, and you must simplify. Given the initial condition, that means when x equal to 0, what is the value of y? You can substitute to find the particular solution. The particular solution means you find the value for c. Let's see this example. Find the solutions of dy over dx equal to x over y. So this is already in general form because you can see right away we have functions of variable x only in the numerator, and the function consists of y only in the denominator. So what we can do next is to separate this variable. So you multiply y with dy and multiply x with dx. Next step is you integrate both sides. So integrate both sides. So integrate y with respect to dy, we get y squared over 2. Integrate x with respect to dx, so we get x squared over 2. And don't forget, because both of integration will give you the constant. For example, this one, the left hand side will give you one constant. Let's say this is c1, and second one, the right hand side will give you another constant c2. What we do is we move this left hand side constant to the right. That means you minus c1 on the left hand side, minus c1 on the right hand side. So that means this one will be minus c1 here, minus c1 here. So this one will cancel out, and this one c2 minus c1. Why not? Because c2 is a constant, c1 also constant. Why not we just replace with another constant c? Let's say we write c. So that means this one will be plus just one constant c. Alright, now let's write this function in terms of variable y only. So we have y squared equal to uh, x squared plus 2c, and y equal to square root of x squared plus 2c. Why not? Rather than we use 2c here, because 2c is a constant. Why not we just write as x squared plus a. We substitute with another constant, a. Alright, this is the final answer. Function y, or the solution, is square root of x squared plus a. Example number 4. Solve 1 plus x dy minus y dx equal to 0. Alright, so first we need to reform this or rearrange this differential equation so that this is in general form. So let's move the y dx to the right hand side, so we have y dx here. Alright, from this one we already can separate the variable. If I divide everything by y and divide everything by 1 plus x, so left hand side I will have 1 over y dy, right hand side I will have 1 over 1 plus x dx. Right, now we can see that all the variable y on the left hand side, all the variable x with the derivative dx on the right hand side. So this side only y, this side is only x. So we have separated the variable. And then next step is we integrate both sides. So integrate both sides with respective dy and dx. So on the left hand side, 1 over y, we will get ln y. On the right hand side, we get ln 1 plus x. This one is in modulus. And don't forget the constants of integration. Let's say this is c. So next, this is actually a solution, but we don't want our solution have a ln. So what we need to do is we can put exponent. We take exponent for both sides. So take exponent on the ln. So exponent ln y and exponent ln 1 plus x plus c. So exponent ln y, exponent and ln, we cancel each other. So you have y on the left hand side. On the right hand side, this one actually we can break down by using the power rule. So this one will be exponent ln 1 plus x multiply exponent c, where exponent to the ln will be 1 plus x multiply exponent c. Exponent c is a constant, so let's write this one as a new constant a. So this is our final answer. Y equal to 1 plus x multiply a constant a. Right, example number 5. Solve the initial value dy dx equal to minus x over y. But now we are given the initial condition, or we are given the condition. So this means at x equal to 4, y equal to minus 3. Alright, first let's solve this differential equation. Dy over dx equal to minus x over y. Separate the variable x and y, so we have y dy equal to minus x dx, integrate both sides, y squared over 2 go to minus x squared over 2, don't forget, plus c on the right hand side. So express this function in terms of y as dependent variable. So y equal to minus x squared plus 2c, and y equal to square root of minus x squared plus 2c. So this is our general solution. To get a particular solution, substitute this one. So this one mean when x equal to 4, value of y equal to minus 3. So substitute here, minus 3 equal to square root of negative x squared. So negative x squared, sorry. Negative 4 squared plus 2c. So negative 16 plus 2c equal to minus 3. So square root, square, take square both sides. Square here and square here. So we get here 9. Here we get 16. Negative 16 plus 2c. So 2c equal to 9 plus 16, 25. We don't need to find the value for c only. No need to divide by 2 because here we have expressed our function y in terms of 2c. So just take this value 2c here. So this one will be y equal to negative x squared square root plus 25. So square root negative x squared plus 25. So this is our final answer. Alright, so take a look at this exercise. Please do the odd question only.